So, welcome to the lecture 2, introduction to object oriented programming. So, in the last lecture we talked about the basic introduction about the objects and the classes, and here right I will start with what do you mean by objects in, let us say, C++ or any object oriented programming. So, object which is nothing but the instance of a class, right. So, I told in the last class, so when we are having, let us say, class A, the small a is an object. So, let us assume, right. So, small a is an object and capital A is a class, right. So, with this object, so assume that in the main I can write like this, a dot, let us say there is a factorial function, right, the factorial member function. So, through this object, so this object can invoke whatever be the member functions it has, right. So, that means this object can access, right, all the members, right, inside the class. So, for example, right, so let us assume there is a function called the member function called factorial, right. So, this factorial function can be accessed. So, object A can invoke this function, right, and then it is going to store in some integer value m, assume that, right. So, this we will do it in the main. So, that means this object A, right, so which can invoke any members, right, all the members inside the class, right. So, for example, time is the class and capital T1 is the object, right. So, time T1, if I write, T1 is an object and time is the class. So, here you have, when you are defining, let us assume the object. So, the object can be tangible or intangible, right. So, in the real world applications, let us assume if you have a chair, bike, marker, pen, table, car. So, these are all considered as the object. So, under which now we have two different objects called tangible and intangible. So, any physical objects like a chair, bike, these are all called tangible objects. So, what do you mean by intangible objects? A banking system. So, assume that I have a bank class, right, under which I have some objects B1, B2, B3, etc., correct. So, now I call this bank as the intangible object. Similarly, institutes or university, alright. So, university I have U1, U2, U3. So, U1, U2, U3 are all the objects, right, and university is a class. So, this is intangible. So, these are all considered as the intangible objects. So, this is the difference between the tangible objects and the intangible objects. So, as we have seen in the last class, right. So, when I am defining, so let us say a state. So, state is nothing but the member data, right. So, the data which is hold, suppose assume that I define int a, right, assume that I define int a and a equal to, let us say, 10. So, it is taking the value 10, right. So, that means this is representing a value of an object. State is nothing but this is representing a value of an object, and similarly behavior, right. So, which is representing the functionality of an object. So, suppose if we define, let us say, bank as an intangible object. So, in the bank what are all the functionalities happen, right. So, the customer can deposit the money or withdraw the money, right. So, these are all considered as the behavior. Or when I am talking about the physical, right, objects, so what are all the functionalities, right. So, if I take a bike, so the bike has to run smoothly, right. So, these are all the functionalities. Or in the program if I take, so what are all the functions you are writing, what are all the member functions that you are writing, right. So, these are all nothing but the behavior. And when I am defining, suppose assume that I define a class A, right. So, under which I have, let us say, A1, A2, two objects. So, now these two are all having identity. So, if I take C++, right. So, when I define, when I instantiate an object A1, so this A1 will be stored in some memory space, right. So, it will have a unique identity, and A2 will be stored in the separate memory space. So, when I want to access, let us say you put C out, let us say A1, right, you want to find out where exactly it is being stored, you might have done in the case of arrays, right. So, assume that you are declaring an array int A of 10 and you try to print this C out A, right. So, can you think what will be the answer? Yeah. So, this will be a base address, right. So, when you define, so in fact array, this you consider as an object, right, array of 10 numbers, and then you write C out A, what is the identity, where it is being stored. So, in a similar way, when I am talking about the objects and classes, A1, A2 are objects here and capital A is the class, and if I want to know, alright. So, A1 will be stored in some place and A2 will be stored in another place, and we can have the unique ID, right. Every object has the unique ID in a Java programming. So, this is identity hash map, alright. So, this is identity hash map. So, A1 has the identity hash map and A2 will also have the identity hash map, alright. So, this is how we have 3 characteristic features of an object, which is a state, behavior and identity. So, the tangible object, right. So, pen, assume that pen is an object, right. So, it will have a name, right, Parker, and color is some golden or blue, right. So, this is known as its state, right. So, pen is an object. So, it has, so either the maid, right, Parker, or you have a golden color, right. So, these are all nothing but state or states. It is like int A comma B, A is a Parker, B is a golden color, right. And what do you mean by functionality, right. So, that is a behavior. So, pen means it has to write, right. The writing is the behavior, okay. So, writing is the behavior. So, as I said, when we have an object A and class capital A and an object small a, right. So, the object is nothing but the instance of a class, right. So, class is nothing but a template or a blueprint, right. So, it may have several objects, the class may contain several objects. So, suppose I am defining, let us say class A, so this has several objects int A, alright, int A1. So, you have double, let us say B1 of 10, right, array of 10 elements, or character C. So, you can have several objects. Similarly, this can have several function name int fun1, fun2 and so on, right. So, you will have a blueprint what exactly you are going to do in this program. So, I can use various objects and various functions. So, one class, you may use several classes, right. So, it is basically blueprint, what are the objects that I am going to use, what are all the member data that I am going to use, right, what are all the member data that I am going to use and what are all the member functions that I am going to use, right. So, which is nothing but the template or blueprint, the complete A, the class A, which has several member data and several member functions. So, I put dot dot dot, that means several member function, you can have function 2, function 3, let us say factorial, right. So, the complete template or complete blueprint which contains objects, right. So, which contains member data and member functions. So, now from here let us say class A, I have object A, right, I have created an object. So, now this A, small a can access, let us say A1, it can access B1 of 10, it can access C, right, it can access the function. In fact, it will invoke those. I can put A dot A1, assume that A1 is taking the value A dot A1, right, or I can write in the main A dot A1 equal to 10, which I can do that, right. So, I can instantiate an object. So, this is what exactly you are doing. So, object is the instance of a class, you have instantiate an object. So, if I consider fruits as a class, right, if I consider fruits as a class, I have objects. So, apple, mango, pear, they are all considered as a objects, right. For the layman point of view, if I consider fruits as a class, so I have apple, mango, pears, they are all called the objects. I hope it is clear, right. Now you know how to distinguish what is meant by class and what is meant by an object, right, or together class and objects. So now when I consider C++ class, right. So class is a group of similar objects, right. So when I write A, I will use the same, right, A1, A2, A3, these are all the objects, right. So they are all the group of similar objects. So 3 objects are there, right. So they are all similar. For example, in the previous case we have seen fruits, alright. So these are all objects and here you have a class, alright. So class, when I consider a class, it is a template from which I can create the objects, right. Class A is a template, so it contains so many, right, the member data and member functions, correct. So when I have the class, so it can have the fields, right, that means the member data, and then I can have a member function. We are going to study the concept called constructors, distractors, alright. So several concepts now we are going to see that. So we have seen only so far, I have in fact introduced only the member data and member functions, right. So we will have several concepts like a constructor, inside the class you can have another class, right, distractor, right. So these are all the concepts that we are going to study under the class, right. So in general when I am defining a C++ class, so it will contain, let us say, member data, member functions. So this extensively I told, and then we will study the concept of constructor, and then inside the class you have the block, right. So inside the class you have blocks, you can have blocks, alright, and then inside the class you have another class or several classes, alright. So in general, so these are all some of them I told because you have distractor also, alright. So a class in C++ can contain member data, member functions, constructor, block, class, distractor, etc. alright. So now the programming point of view, syntax point of view. So how do you define a class? So class, so here you have a keyword called class, you have to use a keyword class, and then it has name of the class. So here you have the name of the class, right. So here we have member data, right, just you call it as a field. First time we are introducing field, last slide we had seen, and member data is nothing but the field, and you can have the member function, right. So you can have, in fact we are going to study several constructors, distractors and all those, right. So here you have, right, so here you have member data, member function, and you have the braces. So starting with the braces, alright, and you are ending with the brace followed by a semicolon. Whereas the same syntax we are going to see in the case of Java, you will not find the semicolon, right. So there is a difference between C++ class and Java class, alright, almost same. You will have a member data, member function, so whatever I told, so it will be there in C++ as well as Java, but the syntax will slightly differ. In the case of Java you cannot find the semicolon, right. So we can take a typical example, whereas in the case of a C++ we should have this semicolon, right. So in the case of C++, so we are having this semicolon, okay. So now we will take a simple example, class student, that means student is the name of the class, and then you have a braces which is beginning, right. So you have a public int id, right. So int id, this is the data member, alright. So this is the data member, float salary, another data member, or you call it as a field, string, right, name, right. So in the case of C++ you put the semicolon here. I purposefully did not put this because I want to distinguish the C++ class and Java class. So if I put semicolon, so you call this as C++ class, right. So suppose I do not put, let us say, the semicolon, right. So if I do not put the semicolon, you consider this as a Java class. You consider this as Java class. Right. So, this is how your syntax goes. So, let us consider C++ initially, we will write a program in Java as well. So, let us consider the C++ class, right. So, with semicolon and I put the semicolon, right. So, you have a class, name of the class, and inside the name of the class you have data member and member functions. So, how the blueprint looks like, right. So, for example, right. So, we are planning to create a class, let us say class home, right. So, when you consider class home, so you will have, right. So, like this. So, you may have a hall, right, you may have a bedroom, you may have a kitchen. So, you are planning, right. So, let us say 40 meter to let us say this is 32 meter, something like that. So, we will plan. So, that means I am planning the class home, right. So, now you will have certain functionalities in home, correct. So, let us say puja room, some name I am giving. So, now you have the functionalities. What are those functionalities? You have design hall. Design hall is a functionality, right. So, write it, or you may have before that you have certain data, right, member data, length, breadth of the complete house, right. So, length of the hall, breadth of the hall, length of the puja room, breadth of the puja room, right. So, these are all considered as the field objects, and then I am going to define the design hall. So, what is the total area, right. So, I will write some code over here, let us say I am going to find out the area of the hall or area of the kitchen, right. So, design kitchen, design puja room. So, this we consider as a class, right. So, starting with class home, so I am ending with the semicolon, right. So, this I considered as the example of a class. So, it means you have the blueprint, right. So, this blueprint has several objects, several member data and the functionalities, right. So, this is how we are building the home. So, exactly you can think when you are building the home physically, when you are building the home, what are all the plans that you are going to make. So, in a similar way when I am writing a class, what are all the member data I require, right, what are all the functionalities it requires. So, these things you have to think and then make a class. So, now we will start working on some programs, right, based on the classes and objects. So, we have studied the extended, right, the definition of classes and objects. So, now you know. So, we will start, right. So, as I am keep on saying, so your prerequisite is required, you should have the knowledge on the basic C programming before object oriented, right. So, that is what the idea of this course. So, with that we will start with the first example, right. So, you know ASH include IOStream exactly like a procedural oriented you are doing, and whenever you want to write the Cin statement you are using namespace, the standard function std, right. So, now I define a class student, right. So, class student. So, these two we had seen, student is the class, student is the name of the class, and then here first we are using the access modifier. So, right now no need to worry about this, alright. So, this is called the access modifier. This syntax we will worry slightly later once I introduce the access modifiers, but before that we are using the data members. So, the first data member is int id, right. So, id is the data member, and string you have another member data member, whatever way you can call it, a string name is a data member, right, string name. So, you are using only data member here, right. So, you are using only data member here. So, now your class is ending over here, this is where your class is ending, right. So, now you go to the main program. So, here line number 10 you have the main program, right. So, in this main program you have student S1, right. So, that means S1 is an object, you are creating an object, creating, or you call it as instantiating an object under the class student. So, now you have this object S1 invoking the data member ID, and ID is assigned the value 18, the ID is assigned value 18. You might have written in your procedural oriented int a is equal to 10, simply you write. So, in a similar way here the object has to instantiate, the object has to invoke, object has to invoke, object has been instantiated over here, S1 is an object. So, this object S1 dot, so the dot operator, so the dot operator which is bridging between the object and the member data or object and the member functions, So, here S1 is the object name, so name of the object, and then we are using the dot operator. So, this is your dot operator, and the right hand side you have member data or member function. So, for example, here member data, right now we are not using any member function in this code. So, the member data is ID, so I call it as a member data or data member, whatever way you call. So, then I am assigning some value, So, this syntax exactly we are using this syntax, exactly we are using this. So, dot operator, and then you are having ID. So, that means the relation between the object name and data member. So, dot is operating as like a bridge, and then it is taking the value 18. I hope it is clear for everyone. Now, let us consider line number 13, alright. So, S1 dot name, object name, dot operator, another data member called name, name is a string. So, I can use the string Virat Kohli, I can use the string Virat Kohli. So, the now next two steps we are going to write a output, So, the output is Cout S1 dot ID. So, suppose if you write here Cout A, in the procedural oriented you might have studied, when you write int a equal to 10 and Cout A, you know the value will be A, the value will be 10 for A, So, that you know for this code you know the output is 10. So, in a similar way you are printing out S1 dot ID and another one is S1 dot name, So, when you run this code, so we will get the output 18 and Virat Kohli, So, when you run this code, when you compile and run this code, you will get the output 18. So, S1 dot ID is 18, S1 dot name is Virat Kohli, So, this you are writing using the class and object. So, the first program that we are using, the basic program, So, the name of the class is student, and then you are instantiate an object S1 under the class student, and then how to give the value for this. So, we are just using the member data or data member, So, two data members we have used here, ID and name, and then you are printing. So, it is like a reading and writing, the initial program kind of hello world, So, reading the value and writing the output, assigning the value and giving the output, writing the output. So, we will see one more example, So, let us consider the class box, let us consider the class box. So, here you have the member data length, breadth and height, length, breadth and height, and the name of the class is ending over here with the semicolon, okay. So, now I create two objects, in the last program we created one object, and here let us assume we create two objects, box 1 and box 2, these are all two objects. So, now it is a usual one, double volume equal to 0.0, So, you are using variable called volume whose data type is double, it is a usual one you might have used in procedural oriented programming, the basic C or basic C++. So, now you have box 1 dot height 5.0, box 1 dot length 6.0, box 1 dot breadth 7.0, this is a specification of box 1, and second one is specification of box 2 10.0, 12.0 and 13.0, So, now volume, we are calculating the volume is box 1 dot height into box 1 dot length into box 1 dot breadth, right. We are calculating the volume, correct. So, if you look at the previous slide, so we defined volume in main, right, and how we can access this length, breadth and height. Now, you can see the object box 1, right, which is invoking height, again the object box 1 which is invoking length, box 1 which is invoking breadth, right. So, we know that, right, box 1 dot height is 5.0. So, 5.0 will be multiplied by 6.0 will be multiplied by 7.0, right. So, this will give you the volume. Similarly, you can see box 2 which is invoking height, length and breadth. So, that means here in this case 10.0 will be multiplied with 12.0 and that will be multiplied with 13.0, right. So, you will get the output. So, the output you are writing volume of box 1, right. What is the volume, right, and volume of box 2, what is the volume, right. So, you can run the code now, right. So, this we have written, defining a class, name of the class is box and you have objects box 1 and box 2, correct. So, you are using one variable volume, right, whose data type is double, and then, right. So, box 1 is invoking and the corresponding height is 5.0, we are writing a simple code, right. So, later stage how elegantly we can write this, right, that we will see. So, box 1 dot height, box 1 dot length, box 1 dot breadth, it is taking the value, assigning the value. Similarly, box 2 height, length and breadth. So, now when I multiply these 3 respective box 1 and box 2, we will get the volumes of box 1 and box 2. So, when I run the code, we will get volume of box 1 and volume of box 2. So, in the next class what we can do, so we will take one compiler and run the code. So, right now in the first introductory classes we had seen, right. So, how we can define, right, the classes and objects. So, in fact, the basic overview we had seen in the last class, and today's class we are more focusing on the objects and classes, and now you know very well what do you mean by objects and classes. So, under these objects and classes we have written 2 simple code, alright. So, I have written the code and then we have got the output. So, in the next lecture what we can do, so we will take a compiler, right, you can use any compiler. So, since all of you have done your procedural oriented programming, right, or basic C up to let us say structures and unions. So, you can start running whatever the compiler that you are using, but in the next class what we will do. So, the 2 programs that we had seen, so we will run with a compiler, with the help of a compiler. So, in this lecture we have more focused on the objects and classes, and we had seen some of the examples, right, how the objects and classes are being defined. So, we have taken the fruit is considered as a class and the apple, pears, oranges, they are considered as the objects, right. So, in a similar way in this program, so the box is considered as a class, right, and box 1 and box 2 are the objects. So, the 2 examples, so various examples we had seen without program, but 2 examples we had seen with program, right. So, the next class we will begin with running these 2 examples. So, with this I am concluding this lecture. Thank you very much.